Welcome again. Now let's discuss about the application of point group. So there are some notes that we need to remember, and what are the application. So with the help of if we know the C1 axis, and if any molecule has C1, CS, Cn, and CnB point group, then all these molecules are polar in nature. So this is the important note that we need to remember. And if a molecule must have a dipole moment, what this means is molecule must have a dipole moment. If molecule has center of symmetry, or we can say in short inversion, so if a molecule has inversion, then dipole moment will be 0. So this type of molecule, so this is the second point. And third important point, if a molecule has SN axis, then it is optically inactive. If a molecule has an SN axis, then it is optically inactive in nature. So let's take an example. Let's take an example of cis CO H2 of whole 4 and Cl2. So the structure of this is polar because its point group is C2V, and we know that the C2V point group, all the molecules are polar in nature. Now let's discuss about the another important topic, which is order of a point group. So what we mean by order of a point group is that it is the total number of symmetry operations present in a point group. So this is called the order of axis. So this is the definition. Total number of symmetry operations present in a point group is called order of the point group. Let's take an example of H2 molecule. So we know that H2 has a C2V point group, and these symmetry elements which are present here is 1 C2 is present and 2 sigma V and 1 identity is present. So the order of the axis is 1 plus 1 for C1 and 2 sigma V, so 2, and 1 identity, so 1. All this combine equal to 4. So this will be the order of the point group H2. For calculation of point group, there is a formula. We can say that for CNB and CNH and DN point group, we use the formula 2n, where n represents the number of C2 axis, and DNH, DND, and its formula is 4n. These are the formula for calculating the point group or order of the point group. So now let's discuss another point group, which is C1. If a C1 is present, then its point group will be 1, and if a CS or CI is present, then its point group will be 2, and CN is present, then its point group will be n. Now let's discuss another. If a tetrahedral point group is present, then 24 order of the axis is present, and if a molecule has octahedral, then it is 48, and if a molecule has isohedral, then its order will be 120. So this is some important formulas for calculating order of the point group. Now here are some examples. So the question will be, there is one question which asked about the calculate the order of the symmetry elements. So these are symmetry elements given in the question. So E, 2C6, 2C3, C2, and 3 sigma D and 3 sigma V. These are the symmetry elements present, or operations are present. So by adding all these values, we can get the order. So 1, 2 for this 2C6, and 2 for this C3. So after adding all of these, we will get 12. So let's get to the next question, which is the point group of NH3. So we know that the point group of NH3 is C3V, and if we want to calculate the order of this group, then we need to multiply. We need to use the formula which we discussed in previous slide. So C and V is equal to 2n. This will be the formula, where n represent the 3. and represent this 3 C3. So 2 into 2 is equal to 6 is the order of the symmetry element. And here is another example. As you can see, its order is 4. Now let's discuss the next topic, which is representation of point group. So there are two type of representation present to describe the first is reducible representation, and another one is irreducible representation. So these representation are the representation of coordinates of point group. So first is reducible representation. It is further discussed in three type of basin, just like reducible representation on 3n Cartesian basin, and the same in vector basin, or the reducible representation as vector basin, and the reducible representation as angle basis. So this is a mathematical part, so we only need to use the application of this. So we use direct formulas, or we can say different symmetry group. We need to write the character in this. So what is a character? So a character is the character corresponding to symmetry elements. We discuss characters according to symmetry element, just like for axis of symmetry, the x which is represented by x, this character represented by x, psi. So this psi cn is equal to 2 cos theta plus 1, and for improper axis of rotation, or Sn, we write psi Sn, which is equal to 2 cos theta minus 1, and for plane of symmetry, or sigma, the character will be 1, and for every plane, just like for sigma vertical, and for sigma horizontal, and for psi sigma d, it is 1 for all plane of symmetry. And for center of symmetry or inversion, we can write a character of I is equal to -3. And for identity last, or we can say E, the value of psi E is equal to 3, or the character is 3. We take 3. So there are some important psi values for C2, psi for C3, psi for C4, and psi for C6. We directly use these values, and it will be easy to remember like this. So for psi character of C2, the value will be -1, and for character of CT, the value will be 0, and for C4 it's 1, and for C6 it's 2, and just like that for character of S2, and character of S3, and character of S4, and character of S6, the values will be from down to bottom, just like for S6 it's 0, for S4 it's 1, for S3 it's -1, it's for -1, for -2, and here -3. So this is generally used character that we use in formation of character table. Now let's discuss the first type of character for reducible representation of molecules as 3n Cartesian basis. So according to this, we use the previous values, just like this, the previous values for character. So to write a character table, let's take an example. To write the reducible representation, let's take an example of H2O. So we know the molecule of H2O. It is just like that. And let's have a axis. We know that axis is X, Z, and this is Y axis. So we know that H2O has a C2V point group. So to write the character table, we have one identity C2 sigma xz, the plane which is parallel to which cut all these elements in parallel, and the another plane which is sigma yz. These are all the planes or symmetry elements present in C2V point group of H2. So to calculate the reducible representation, we first check the number of unshifted atoms. So this is the first column that we write here, number of unshifted atom, and the next step we discuss is the character, or we can say contribution per atom. So this is according to 3n Cartesian system. So these are the values that we write, and now and after multiplying this or getting product of this, we will get the reducible representation here. So this is the point group C2V or H2O, and we write the as you can see, if we put identity in this molecule, so number of unshifted atoms will be 3. So nothing will be changed after putting identity. So total number of atom is 1H, 1 oxygen and 1H. So total number of N value is 3 here. So 3 will be identity. And if you put a C2 axis, just like that, if you put a C2 axis, so these hydrogen will change or interchange with each other. This oxygen will remain in 1. So the number of unshifted atoms after putting C2 axis is 1. And after putting a sigma xz plane, so according to xz, this graph, the xz plane, so the number of, so after putting xz plane, the number of unshifted atom will be 3, and for xz plane 1. Why 1? Because of horizontal plane will be there, so all this will reflect, these hydrogens will reflect, so 1 will be unshifted, this oxygen will remain in the same position. And we know that the character, when we put identity, so the character will be 3 according to this chart. When we put identity, the character will be 3. So this is where this value come from. And if you put a C2 and then this is the C2, so the character will be -1. So here -1 will be here. And for sigma, for every sigma that discussed, the value will be 1 and 1. So the reducible representation of this molecule will be 3 into 3, so 9, -1 into 1, -1, and 3 into 1, 3, and 1 into 1, 1. So this will be the final reducible representation for this molecule. So there is the second method, which is reducible representation on vector basis. So here the character corresponding to each symmetry element will be 1. So here we do not have to check anything. For every number of unshifted vector, the contribution per vector will be 1. So here is one example. Let's take an example of H2 again, and we know that it has a C2V point group, and it has identity C2 and a sigma xz and a sigma yz. So number of unshifted vector, why? Because we are checking the vector basin. So number of unshifted vector will be 3, because the 3 elements are present, and we know that 1 is here, 1 is here. This oxygen will have this type of vector, so 3 vectors are present. And after putting identity, and after putting C2, 1 will be here, and it will be same just like in the previous. So and the contribution per vector will be 1 1 1 1. So the reducible representation here will be 3 1 3 1. This is the answer. And for the third one, the reducible representation on angle basin. So here it is also the same type of example can be seen, and here the contribution per angle will be 1. So here also we put the same value as compared to as in the previous method. So now we learn how to draw a character table. So it is an important question that asked in CSIR NET exam in character table. So how do we form a character table? So it is the collection of, so character table is the collection of all the information about the symmetry of the molecule in the table. It's called character table. So formation of character table can be done in character table just like that. There is one column here and a column, and third and fourth columns are present. So first column here we represent the irreducible representation, number of irreducible representation, which is equal to number of Mulliken symbols, and which is also equal to number of classes. So here these values are present. In second column we contain many sub columns, and the number of sub column is equal to number of class. This is an important observation that we see in character table. And the third is translation and rotational motions. So in third column translation and rotational motions can be seen. And in fourth column quadratic equation, which used to tell the IR and Raman activities. So the values which present in this column can tell about all these Raman and IR activities. Now let's discuss about the what is order and what is class. So the total number of symmetry operation is called order, and the number of total number of types of symmetry operation is called class. So according to the C3P point group, how many classes and orders are present? So we know that order is a total number of symmetry operations. So here one identity, 2 C3s and 3 C sigma V's are present. So the total will be 3 plus 2 plus 1, which is 6. So 6 will be the order of this C3P point group. And if we talk about class, it is a type of symmetry operation that are performed here. So one identity is present, one C3 axis is present, and a sigma vertical plane is present. So 3 will be the class of this molecule. Now let's discuss a question. So a molecule contains the following symmetry operation: E, 2 C6 and 2 sigma, 2 C3 and C2 and 3 sigma D and 3 sigma B. The number of class and number of order of the symmetry point groups. So these are point group given here in the question. So we just need to calculate the number of classes and number of order present. Also number of class will be the number of type of symmetry operation that are being performed here. So 1, 2, 3, 4, 5, 6. There are 6 classes are present. So 6 will be the class, and number of operations will be its order. So 1 E plus 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 will be the order, or the total number of symmetry operations is 12. So here this will be the right answer. Now let's discuss about the first step, which is the formation of second column of character table. So how do we form the second table, second column? So it contains, let's take an example where if the order is 4. Now let's discuss about the first rule, which is number of class equal to number of Mulliken symbol. So it will be the first step for formation of this. So number of class equal to number of Mulliken symbol, or in short MS, and the number of irreducible representation. So and equal to number of subcolumns. So this is then the second rule speak about the no 2 IR has the same value. This is a very important line in which no two IRs, just like this and this, the values of these are not equal to each other, so it will be unequal to each other. And the third rule speak is the sum and square of any IR equal to order of the group. Sum and square is equal to order. So by adding this 1 2 value, just a1 square plus a2 square plus a3 square plus a4 square equal to 4. So these values should be equal to order. If we add these values or sum and square, the value will be its order. Now let's talk about the fourth rule, which speak is the sum and square of xe, which is the identity or character identity. So order of character of identity is equal to its order. So we know that a1 square plus b1 square plus c1 square plus d1 square is equal to 4. So 1 plus 1 plus 1 plus 1 equal to 4. So 4 is equal to 4. So b1 equal to c1 equal to d1. This column will be filled. This values is b1, c1 and d1. So if you know that the identity the order के बराबर होती है, so character of the identity is also same. And the rule fifth for formation of character table speak is the two IR are orthogonal to each other. So what's the orthogonal mean is when we summation of all the IR1s and into IR2s is equal to 0. These are the values. So by taking this into account, 1 into 1 equal plus 1 into b1 plus 1 into b3 into 1 into b4 is equal to 0. This is the third. So we can apply this on all the IR1s and IR3s. So by taking all the previous rules into account, we will get these values for b1, b3 and b4, and same can be applied for this and this. So the character table's second column will be completed now. After formation of second table, we can form the first table. So there are some rules for the formation of first table. So according to first rule, the character of identity or the character of E, if it is 1, if it is 2 and if it is 3. If it is 1, then the values can be A and B for the first column, and if it is 2, then it will be E, and for 3 it is T. And the second rule, which is the important rule, so according to which, so what is a symmetrical means? Symmetrical means plus 1 value in the character table, and unsymmetrical means minus 1 value in the periodic table, in the character table. So if the symmetry or the plus 1 value is present with respect to principal axis or the C2 axis, that is like this is the principal axis according to C2 point group. So if 1 value is present, so A will be there, and if unsymmetrical or minus 1 is present, if it here minus 1 is present, so this value will be B. So third rule that come for the formation of the first column is if the subsidiary axis or the subscript is 1, and the second and the fourth rule is if symmetry with respect to vertical plane or sigma v, in this case sigma v is present. So if the value of this is minus 1, subscript is taken, and if unsymmetry with respect to vertical plane, then subscript second is taken. So the value of 1, 2 and 1 or 2 is decided with this rule. And the fifth rule that is speak for the formation of that is if symmetrical, which is 1, with respect to sigma h, then dash is used, and unsymmetrical with respect to sigma h, then double dash is used. And the sixth rule, that is symmetrical with respect to identity, if identity is present in the point group, then G is used, and unsymmetrical is minus 1 with respect to identity, then U will be used. So according to by using this all the rules and formation of character table, first column, then identify the Mulliken notation for the following IRS. So these are the IRS given. We need to find the Mulliken notation. So if identity is present in 1, then it will be A or either B. If Cn axis is present, so A will be there, not B. And if C2 axis, which is subsidiary axis, and it is unsymmetrical, so 2 will be used in the subscript, so A2 will be there, and A1 and B1 will be crossed from the options. And identity is present, so according to this identity present, then U is used, so U is present also. And for sigma H, if sigma H is present, then single dash is used, and unsymmetrical with respect to sigma H, then double dash is used. So here in sigma H it is -1, so the value will be, this will be the right answer for the question.